In December 1972, humanity left the Moon. Apollo 17 marked the final mission of an era that had changed history. Astronauts walked across gray dust, collected rock samples, and looked back at Earth hanging in the darkness of space. Then they departed. Many believed they would soon return. They did not. Years passed, then decades. The launch pads grew quiet. The Moon became memory. What once felt like the beginning of a permanent future slowly became a symbol of the past. For more than 50 years, no human being stood on the lunar surface. No new footprints appeared. No bases were built. No cities followed. Humanity had reached another world, and then stopped. The reason was not mystery. It was cost. The Apollo program had been created during the Cold War. It was fueled by political competition, national pride, and enormous funding. Once the United States won the race to the Moon, urgency began to fade. The missions were expensive. Public attention declined. Governments shifted priorities. Instead of returning to deep space, focus moved closer to Earth. Space stations were built. Satellites expanded. The space shuttle era began. The Moon remained above us, visible every night, but increasingly ignored. For a generation, it seemed possible that Apollo had been both the first chapter and the last. But the Moon was never empty, and it was never useless. As technology improved, scientists began to study it again with new instruments and new spacecraft. What they found changed everything. Near the poles of the Moon, inside permanently shadowed craters, there appeared to be something extremely valuable. Water ice. Frozen reserves hidden in darkness for billions of years. That discovery transformed the Moon from a dead destination into a strategic resource. Water can support life. It can be purified for drinking. And when separated into hydrogen and oxygen, it can become rocket fuel. Suddenly, the Moon was no longer just a place to visit. It could become a place to operate from. The Moon is also close. On average, it is only 3 days away. Mars can take months. That makes the Moon an ideal testing ground. Before sending humans to distant planets, space agencies need to learn how people survive far from Earth, how habitats perform, how equipment fails, how crews respond to isolation, radiation, and extreme environments. The Moon offers all of these challenges while still remaining within reach. If something goes wrong, help can arrive far faster than it could on Mars. That is why many engineers see the Moon not as the final destination, but as the training ground for everything beyond it. To make that future possible, NASA launched a new program. Its name was Artemis program. In Greek mythology, Artemis was the twin sister of Apollo. The message was clear. This was not a repeat of the old missions. It was the next generation. The goal was larger than planting flags. Artemis aims to create a sustainable presence on and around the Moon. Not one mission, not one landing, but repeated access, infrastructure, habitats, science stations, and eventually a foundation for deeper space travel. It also represents a new era of inclusion. NASA announced that future lunar crews would include the first woman and the first person of color to walk on the Moon. The next footsteps would belong to a different generation. The first major test came in November 2022. Artemis I launched without astronauts on board. Its purpose was to prove that the system worked. The mission used the Space Launch System, or SLS, one of the most powerful rockets ever built. At the top sat Orion, a new spacecraft designed to carry humans beyond low Earth orbit. the rocket rose with immense force, sending Orion toward the Moon. It traveled around it, tested systems in deep space, and returned safely to Earth in December 2022. For the first time in decades, hardware capable of carrying astronauts back to lunar distance had flown successfully. The silence after Apollo was ending. The next major milestone became Artemis II. This mission carried a crew of astronauts around the Moon and safely back to Earth. It launched in 2026. They did not land. Instead, the mission was designed to test life support systems, navigation, communications, and human performance in deep space. For the crew, it was the first time humans traveled that far since 1972. As Earth grew smaller behind them, they entered a journey few people in history had ever experienced. They passed beyond low Earth orbit, traveled around the Moon, and witnessed its far side below them. For the first time in more than half a century, human beings had returned to the vicinity of the Moon. Artemis II successfully reopened a path that had remained closed for decades. It proved once again that humanity could travel deep into space and come home safely. Then comes the mission the world is waiting for, Artemis III. Its goal is to land astronauts near the lunar South Pole. NASA currently targets 2027. Unlike Apollo, which visited equatorial regions, this mission targets areas rich in scientific value and possible water ice. The landing system is expected to involve new technology, including spacecraft developed through private partnerships. If successful, humans will once again step onto the Moon. But this time, they will arrive with a different purpose, not simply to prove it can be done, but to begin learning how to stay. Returning once is impressive. Returning repeatedly changes history. NASA and its partners have proposed a long-term architecture. One part of that plan is Gateway, a small space station that would orbit the Moon. Gateway could support crews, store equipment, and serve as a transfer point between lunar orbit and the surface. On the Moon itself, future missions may deploy power systems, rovers, science labs, and eventually habitats. Astronauts may remain for weeks, then months. Each mission would build upon the last. Piece by piece, humanity could create its first permanent presence beyond Earth. If resources can be used on the Moon, space travel changes. Launching fuel from Earth is expensive. Every kilogram matters. But if water ice can be converted into fuel on the Moon, future spacecraft may refuel there. That would turn the Moon into a gateway, a place where missions to Mars and beyond begin. The Moon may become what ports once were for ocean exploration, a frontier base, a supply point, a stepping stone to unknown worlds. Yet none of this is easy. The Moon is hostile. Temperatures swing from extreme heat to brutal cold. Dust is sharp, abrasive, and difficult to control. Radiation levels are higher than on Earth. Landing safely requires precision. Operating reliably requires constant engineering. And beyond technology, there are other challenges. Budgets change, politics shifts, schedules slip. Large programs often face delays. Returning to the Moon is not only a scientific challenge, it is also a test of patience, coordination, and long-term commitment. The United States is not alone. Other nations are also planning lunar missions. China has announced ambitious goals. Private companies are developing landers, rockets, and surface systems. Once again, the Moon has become a place of competition. But unlike the Cold War, this new race includes commercial industry, international partnerships, and long-term economics. Whoever succeeds first may help define how humanity expands into space. More than 50 years ago, Apollo proved that humans could reach the moon. That achievement changed what people believed was possible. Now, Artemis seeks to answer a different question. Can we live beyond Earth? Can we build in places once thought unreachable? Can another world become part of human civilization? The next landing will not just repeat history. It may begin a new chapter. For generations, the moon was something people looked at, a distant object in the night sky. Soon, it may become something more, a workplace, a laboratory, a base, perhaps one day, a home. Humanity once went there to win a race. Now we return to build a future. And the next footprints pressed into lunar dust may not be temporary. They may be the first steps of a permanent presence beyond Earth.